Here I'm gonna cover single slit. This problem is taken from OpenStax chapter 4, problem number 22. So the problem is given with the wavelength of light of 589 nanometers, and it is a single slit with the slit width of 7.5 I don't know how to say that unit, but mu m, and it is asking us what is the theta 2 in this diagram here, and what is the maximum value of p. So we see here is I draw like a single slit diagram. This would be the slit here, and it's saying the slit difference is 0.75 mu m. So here is it, and here it has diffraction. Here is that diffraction, and then at each point of diffraction, it's gonna generate two waves, and that two waves would interfere to form this pattern, and at these points, these are some constructive interference, and these constructive interference would give us the central fringes, and the destructive, which is here on this line, is the destructive interference, and this would give us the minimum. So here we have p equals to 1 corresponding to this minimum. This minimum is 2, this minimum is 3, and this minimum is 4. So as we approach the problem, the first thing is we're using the equation for single slit, and when we use the equation of single slit, we just plug in the values of A and the wavelength of the light, and we get theta 2 is equals to 9.04. And when we're calculating the maximum number of dark fringes, then we're using this inequality. But since p has to be 1, 2, 3, 4, 5, and so forth, so when we're simplifying to this step, this whole thing is positive, so so this thing would never goes negative, so this is -1 to 0. But for p, it starts with 1, so here I convert 0 to 1. But other than that, it's just some numerical calculations. So we have the highest order of maximum, the minimum would be 12.